Alright, welcome to the spin around direction of travel video. It's kind of a long title, I know, but what we're going to do is take a look at how to get particles to spin around the cross product or the vector of direction of travel. We're going to go ahead and start off. We're going to make a name for this. It's going to be called spin around velocity. And inside that, we know that we're going to need to create some particles, so we'll create a rule here called birth. And actually, we're going to call this birth on path. We're going to go ahead and save this out itself as a black box because we're pretty sure it's going to be useful. We're going to go ahead and create a spline for this and rely on a max node. We're going to use the iterator because what we want to do, describe this beforehand, is we want to sample a bunch of points around this spline, create particles around there, and then have those particles all kind of move out away from the center, and then we'll see them spin around the perpendicular axis like this. So let's go ahead and get started. We've got a birth. We're going to use an iterator because we want to be able to perform multiple commands on a single sample of time. We're going to go ahead and just set this right now to 10. And what we're going to do is actually sample that path information. So we're going to use a position helper called path position. And we need to pick that object we're going to be using. We're going to set it into relative mode, so it does not use world units, but instead just uses a relative 0 to 1 value. And fortunately, the iterator, if you haven't heard already, it has several different outputs based on the number here. We've got a count of 10, so as per sample, it's going to output 10 values. I think it's 0 through 9. And then number normalize is actually also going to be outputted, and that's going to be a nice 0 to 1 value, or 0 to almost 1. We're going to connect that number normalize to position because it corresponds most directly with 0 to 1 of the path length. So, and of course we need to generate some particles. Let's grab a generator. Let's take position born, and let's do this. Let's actually make a group for these guys. Let's call them boxes. Pretty simple. Generate boxes. We're going to generate a pistol shot of one box particle per call. And the reason we're using per call is because we're going to have the iterator control this position born. So every time iterator sends out a value, which is a call, every time it sends out that value, this position born is going to update itself by creating one particle. We're going to go ahead and set some other parameters here, just like that. And what we're going to do is we're going to take the path position. What's happening is iterator is outputting all these values into position, and we're going to take that ending position and use that to control where that particle is created. Let's modify the boxes. Let's make them kind of a bluish color and set them to be ticks. We'll come up to Master Dynamic, turn Edit on the Fly off so that we get real-time updates, and scrub to put it into effect, and now we see those particles being created there. So here's the nice thing about this birth on path dynamic set that we just created, is that as we change the iterator count, you can see that the spacing between all these particles is exact. Okay, so let's go ahead, and we don't need very many of them. Let's do 8 would be fine. And what we want to do, as we said, is we want those particles to move away from the center and spin around that axis. So we're going to take a look at how we can do that. We'll call that dynamic set move and spin away from. Just give it kind of a descriptive name. And what we want to do is affect the boxes group, and we know we're going to need its velocity. But here's the thing: in order to get the boxes to move, to get all of them to move out from the center of the object, we're either going to need to do it in a couple ways. One way would be the easiest way, which is to use a helper node, and we'll just then calculate with the distance operator. And you remember distance operator, position 1 is our starting position, and position 2 is our ending position for generating that direction output. We want these particles to be moving from here away there, so that the direction that we definitely want, this is our node's position and this is our particle position, we definitely want that vector to be calculated going out this way. So we're going to think, well, if our starting position, you remember from our direction video, position 2 can be thought of as the starting position, and position 1 is kind of the ending direction position. So what we'll do here is we'll say the starting position is going to be, the starting position will be the position of our node, and the ending position is going to be the position of our particle, our box at birth. And what we can do then is just go ahead and we'll throw in a velocity, and we're going to take a look at some other controls we want to add to this. Velocity, we're going to expose the direction input so that we can take that direction there and put it there. Let's go ahead and just scrub and see what we get. Right now we don't get much, do we? That's because we did not pick a node yet, so that would be helpful. So there's our circle. Okay, and one of the things that's happening is you can see it's generating particles every frame. That's because our iterator is still running. We need to control when this iteration happens, and we're going to do that right now with the time interval. We only want to create them once, so from 0 to 0 is fine. It's only going to create one set of particles now. And you can see that direction is clearly moving them away from. And remember, that is because we chose position 2 as our starting position, which was here in the middle of this spline, this node. And position 1 is our end position. It's the direction towards which we calculate that direction. It's the position towards which we calculate the direction. Okay, so that's how we get the velocity direction, get them moving away from. That's all great. Let's come back here to where we created these particles. We'll move that time interval to keep a nice, correct order of operations. And let's go ahead and use a black box basic called size shape, since we want to go ahead and affect our particles. We want them to be cubes. Size of 5 is great. Let's come up to the boxes group and say show mesh, so that we see those there. Okay, now you can see they are oriented, and actually what we'll do is we'll bring in an object here. This is going to be included on the DVD. It's called the well, actually, let's use the axis helper labels. This particular one is clearly rather large, so we're just going to scale that down to a more appropriate size. And of course, we could have done this with the normalize option here, but we're just going to do it right now. Reset the transform, convert it back to poly. Pick that object, disable the standard shape because we do not want that. So now what we get is we get the ability to see how they are oriented in space, these particles. The particle alignment was not set at all. You know, their alignment was just left at the default. Let's go ahead and take a look and see what the path position would do to them. And now we can see that it changes it dramatically there. We'll explore both with and without that alignment. In the first case, let's go ahead and disable that alignment just so we can see exactly what we've got. Okay. Sorry, a little too much navigating there. And what we want to do is we want to do a few things. One of them is we only want this velocity to affect these particles when they're born. We just kind of want to give them an impulse to start moving at one point in time and then no longer affect them. The way that we do that is we're going to control that. We're going to control the on of the velocity. We can control when that turns on and when it's valid by exposing its on input, and we're going to use a condition, particle age, and say when these particles are born, then this output's going to be true, and set that velocity. It doesn't make any visual difference right now, but logic-wise, what it does is it tells these boxes, it checks and says, okay, well, you've just been born. Go ahead and apply a velocity. On the next frame or the next sample after the particle's been born, this rule is no longer valid, so it just gets skipped, and it's not going to continue processing all the time. The reason we do that is because if we had other rules further down in time here, or down in the order, that affected the velocity, we could get into a situation if we did not have the particle age on there, that these other velocities would be interfering with this velocity. And in most cases, they would overwrite this previous velocity because it's higher up in the tree. So the last thing that gets evaluated is the one that is going to affect those particles. Sometimes that's cumulative, depending on the settings that you make. But right now, we just want that velocity to only impact at birth and happen at birth. Okay, that's great. What we want to do now, as we said, is we've got those particles moving out. We want them to, each of them, to spin around the perpendicular axis around which they're moving. So let's do this. We can go ahead and use all of these operators already in here. We're going to clean them up a little bit. And we're going to take the velocity. We're going to use another distance. No, I'm sorry. We want to take the velocity and we want to calculate what's called a cross product. We've got some math videos if you need to take a look at those. Here we're going to come down to a black box, vectors, and we're just going to use one called VOPs, vector operations. And you could use, we actually have one already set up as cross product, but VOPs is easy enough to modify. Right now this is set up to just do vector 1 plus vector 2. We're going to change that and calculate the cross product by putting in an X there and pressing enter so that the expression evaluates. So now what we do is we're going to take the velocity. We'll take the velocity into vector 1, and right now we're going to go ahead and just multiply by the Z up direction. And then what we're going to do is add a dynamics operator, a spin. We want that spin to be user defined and not random. And we want to set the spin axis here. And actually we're going to go ahead and normalize that vector and make it a unit vector. So it's nice and just a direction. Okay, now our spin is a little slow. Let's drop our spin time down to 1 revolution per second. So now we can see all of our, well, let's get into a good view here. And we don't need this anymore. Let's hide that. Okay, so what we're getting is, like, let's take a look at this particle right here. We can see that it is rotating around an axis this way. Oops. And in fact, all of them are rotating around. We've got their vector, the direction they're heading, and then there is a perpendicular director, or perpendicular vector there, an axis that we've defined with this math, which is our direction of travel, our vector, our velocity, multiplied against a value of a vector of 1, which basically points straight up. So what happens is, in math terms, I'm going to try to draw this. So if this is my direction of travel, and then we have this z direction pointing straight up, when we get the cross product of these two, what happens is, make sure I've got this correct in left-hand coordinates, the axis ends up going out here. And one of the ways that we can actually explain this also is to take a look just at this helper here. If we have a y vector going directly forward in y, and we have an x vector going off in the x-axis, the cross product of y multiplied by x is going to be z. And in our case, really kind of what we have is we have, let's whip this over. Oops, now we're really mucking it up. I was going to say that as our yeah. In our case, really what we're doing is these particles are moving in a specific direction, say it's y, we're multiplying by z, which is just straight up, and so we get this x vector, or this x-axis, which is what they're rotating around. Sorry, we're kind of mucking this one up a little bit. Let's take the alignment and stick that into the position born so that it actually controls their alignment. We'll see this a little bit better now. What happens is, now you can see them all kind of rotating around their y-axis. And the reason for that, of course, is you see our x-axis is pointing in the direction that we're traveling, and we're multiplying that direction of travel, the velocity, by 1, which would be the z. So remember, we're traveling on x, we multiply by z, we get that y-axis there. And that is the axis around which we spin. Okay, one of the things that we want to do also is take a look at how can we get them. You see they're all kind of rotating backwards, kind of backspin in the direction of travel. If we want to switch that around, all we have to do is make this a -1, and now they will kind of rotate forward over that. So this is a little bit about understanding how to use the cross product in order to tell our particles to spin. One of the neat things about thinking particles is you could actually disconnect this unit vector and just use the actual vector and kind of explore on your own what changes will occur when you make these kind of changes in the logic. You can see that one did not make any change, so we probably don't need the unit vector. Even though the actual vector might be different, what is happening is the axis input, you can see, is a direction type. And so whatever vector we feed in here, if we were to say add a vector that's like very large values, it won't make any difference, at least on the direction input. What happens is this vector gets converted into an actual direction. The operator wants a direction input. It's getting just a raw vector of very large values, a length greater than 1. And so what it does is it converts that into a direction. And of course, this axis that we've defined here is causing some different results than what we had before. What we want to do, of course, is go back to our nice velocity, meaning our direction of travel and speed, multiply that against -1, get the cross product to get the axis to spin around, and in this particular case we've got I think it's rotating around -1, so it's rotating forward. It's kind of spinning forward. Okay, so that's a little bit longer explanation than I intended, but little bits of extra info I hope are useful. We're going to go ahead and save out this file under the projects TP4 video scene files. This one we will call, let's see, yes, let's call this one spin around velocity cross product. Okay, and we're going to go ahead and also save out this birth on path as a black box so that we can use it later. Let's go ahead and do this. We're going to do a save. We'll save it under tutorials. And remember, particle groups after loading, in this case it's not a very complex system, it's just boxes. We'll say either exist or create. We might have to change that if we wanted to use it on a different group, but this is fine. And definitely what we can do is save out this setup here where we take just these 3 operators. And we'll go ahead and do a save, and we'll save this into tutorials. and we're going to call it spin around, or spin by velocity. And of course there are no groups involved, so we'll say none. Okay, let's go ahead and save this file, and we're going to reset, and we're going to go ahead and use that black box again real quick. We'll just create a very simple setup where we draw some particles with particle generate or particle draw. We'll create a couple particles, a few particles, and let's make their lifespan a little more longer. Let's use a black box to set their shape, size, and shape. And cubes should be fine, size, no variation. And then let's go ahead and let's tell those particles at birth, give them some velocity. Spherical, random. Set their speed to 100 with some variation. And let's go ahead and call that black box we created. It's under tutorials, if I can find that. It was spin by velocity. And so we get just those three operators again. And here's what we'll do. We'll expose the velocity output, connect that to the vector, the VOPS, connect the particle there. And now what's going to happen is, based on whatever direction would help to show the mesh, let's make them a little bigger. Let's actually turn off it on the fly too. So now what'll happen is, as these boxes, whatever direction they're moving, you kind of have to pay close attention to their direction of travel in order to see that the axis that they're spinning around is being calculated correctly. But you can see this guy, for instance, is moving up this way, and he's clearly spinning across this axis. And let's check this guy moving down here. This guy is, yeah, this particle right here on the bottom. It looks correct. Also, it's going down, and it's. Let's take a look at it from the top. Which one is that? That must be this guy right here. So we can see over time it moves a little bit in this direction. So it should have kind of a spin around that axis. Oops. And which it does. Okay, so that's a pretty easy way how we can use some vector math, cross product of the velocity multiplied by, in this case, z down, in order to generate a perpendicular axis around which we can spin. So let's go ahead and move on.